Hello, students. Good evening. Now, today we can spend some time on this extra book called Exam Focus 4. It has tons of questions, and they are all very interesting. Before that, I want to mention a little bit about the test on Friday. I marked it on the day yesterday. And a lot of you got full marks, which is very good. But I still want to see how you perform on the last question. So since the paper has already been uploaded, I think you can spend some time and finish it and upload the answer to the final question. This can be done during this weekend. Now look at this question in the Exam Focus 4 in your textbook. Now, if you don't have the textbook with you, I think maybe you can screen cap. Okay, maybe you can screen cap. Now later on, when I show you the exercise, you can also screen cap. If you have the book with you, then you don't have to. It's on this, I think it's first page of this. Question 1. Consider a function f of x, a rational function. I don't know if you characterize functions. I do. I say, oh, this is a rational function with quadratic divided by linear. I also do that subcategory as well. Anyway, it is given that the range for the following ranges of x, the signs of f prime and f prime prime are shown. Now there are a lot of information contained in this table. For example, you can see at x equals to -2. Originally, the function is undefined. And also, the first derivative is undefined. The second derivative is undefined. You can see at x equals to -2. And all that. Perhaps negative, 0, positive, these definitely going to be useful. Now look at the question. Find all maximum and all minimum points and points of inflection of the graph of f of x, if any. Now, if this table is given to you, I don't think this is entirely new to you because in the homework you've done so. Now there are questions like this, and in the test there was a question like this. So how do you present your answer? The signs are given to you so you don't have to derive yourself. I know you can. Maybe your first reaction is to derive, but you don't have to anymore. Let me choose a color. So part A. You will skip the differentiation and then you will go to solve immediately. Solving f prime x equals 0. We have two solutions, x equals -4 or x equals 0. I just read it from the table. I don't have the equation. I just read the table. okay? And then when you have these points, they're not called turning points. Right now, before the test, I don't know what test you're going to use, but before the test, they should be called stationary points. So do not use the term wrong. Stationary points. So these are stationary points. Okay. And then let's do the test. Now also from the table, we know that you can redraw it. X smaller than -4, X equal -4, -4 smaller than X smaller than -2. This one is 0, -0, positive, meaning -0, positive. Therefore, we know this is a minimum. We know this is a minimum. So I will find out -4 and the value for Y. I'll just do rough work for this one. -4. So 2 minus -4 minus 16. -4 plus 2. It's -18, -2. So 9 is a minimum point. Okay. And also the other one. -2 smaller than 0 equals 0, X bigger than 0. Positive 0, negative. So positive 0, negative. So 0, 1 is a maximum point. Now, after this, you will say, oh, these two are turning points, but not necessary. Not necessary. Oh, you say this is a minimum, this is a maximum point. That's okay. Now, pay attention. I use a minimum point, indicating this is a local minimum. If it's a global minimum, it's the minimum point, right? That's just something that we do. You may not know, but we do all the time. Okay. Now, how about the points of inflection, if there's any? Similarly, solving f prime prime equals 0, you will have there's no solution. There is no solution. Okay. But does that mean we don't have any point of inflection? Not necessarily, because there's still some other points that may qualify. You should also notice that f prime prime x is undefined at x equal 2. When it's undefined, you should also test it. Okay. And from the table, you can see, oh, there is a change of concavity. Do you see? Now you can say from the table, there is a change of concavity at x equal 2. Now, usually that would mean there is a point of inflection. However, you must say, however, f of x is undefined at x equal -2. Therefore, there is no point of inflection there. Otherwise, there will be. Now, if you can find a point there, if f of x is defined, then there is one. But since it's not, you don't have one. Now, with these two conclusions, there is no solution, there is no point of inflection, then you can say there is no point of inflection on the curve. Okay, now the entire process is still the same. Now, if you have to do differentiation yourself, if you don't have this table given to you, then you must work out all the signs. Right? You work out all the signs, and then you do all the, how do you find the maximum, minimum? How do you find the point of inflection all by yourself? That is also expected. But with the table given, I think it's simplified. Don't you think so? You don't have to do the quotient rule. You don't have to factorize. In the test, I give you a question like this because I want to shorten the test time. Because I heard you only had 20 to 25 minutes. And with the table given, I think it's possible. It's possible to finish. Now, part B. Find the asymptotes of the graph of f of x. Now, this question, I don't think you can use this table anymore. Now, some students still don't understand the concept of asymptotes. Like, where are they? Like, why is there one? How do you know there is one? Like, it's still very mystical. I can imagine in some of the you're new to this, so I can imagine that. You just see the teacher, I mean me, oh, get this one, and then get this one, get this one. And sometimes I don't get one. Sometimes I don't even set out to find, oh, the horizontal one. No, I just don't do it. And then there isn't one. Now, sometimes I think because there are 3 types, and obviously I know whether or not they exist, and I will only set out to find them when they exist. If they don't exist, I don't even write it. So I think it's time for me to explain in detail again, the first time during the lesson, the second time in the extra lesson, to you, why do they exist? And how do I know they exist? And when they exist, how do we find them? There are 3 types. Maybe I move it a little bit to the left. There are 3 types. Horizontal. Oh, sorry, I shouldn't do it. I do vertical first. Vertical, horizontal, and oblique. Maybe this. I don't know if you see. Now, one line. This line is the asymptote. Asymptote. And the blue line is the curve approaching. Okay. Now, why do they exist? This one exists because the curve is broken. Now, like tangent, the curve tangent, it's broken. On the domain, there's something undefined. Therefore, on the left, there is some curve. On the right, there is some curve. So you will see that, oh, this is the curve on the left. This is the curve on the right. So in the middle, there's nothing. No. So that line must be the point, it must be the asymptote. In formula, you will see a limit. In formula, you will see a limit. You will see that there is something equal infinity. Could be positive infinity, could be negative infinity, to the left and to the right. Sometimes positive infinity, sometimes negative infinity. Basically at A, this position at A, I say this is to the right, this is to the left. So to the right, to the left, maybe it's infinity, maybe it's negative infinity. And if you find this, and there is an asymptote. And usually this place is where the function is undefined. Okay. Not always, not that, oh, sometimes when the function is defined at a place, but there is no point of inflection. Sorry. Forgive me. Sometimes when the function is undefined, but there is no asymptote there. I don't know if you noticed that. Let me give you one example. It's not very common, but they do exist. Okay, for example, this one. Y equal root x. Okay, look at this one. Y equal root x. We know the domain is x is greater than or equal to 0. Right? So at 0, I mean, to the left of 0, on the left-hand side of this graph, I mean, to the left-hand side of the y-axis, here, this part, it's undefined. It's undefined. There's nothing there. However, now you can say, oh, it's broken there. You can say it's broken. However, there is no asymptote there. Simply because there is no infinity. Now, you cannot find this on this curve. You don't have anything that tends to infinity at any point. So I say, oh, if the function is undefined, then usually you will find an asymptote there, but not always, not always, not always. But for something like this, for example, like this, you will find an asymptote. You will find, because when x tends to -2, you will get infinity. You will get the limit equals to infinity. Later on, I will show you. So that is the first type, where the function is broken and when the curve goes to infinity, and that is the asymptote. Second type, horizontal. Now, horizontal on the graph look like this, okay, on the graph. Now, in formula, it means there is a limit at infinity, another limit f of x equal, let's say, a value b, maybe value b, but when x turns to infinity, another limit. Basically, this is b, this value is b, horizontally, the value is b, and the function is going closer and closer to b. Now, if you have a limit, if you find a limit like this, then you find the asymptote. Okay, last type. Last type, there is a limit, but it's not, oh, a simple limit when x tends to infinity, y tends to, it's not something like that. It's the limit between this line and this line. Now, let's say this is f of x. And let's say this is mx plus c. This one is f. This one is mx plus c. One is a curve and then the other one is a straight line. So how do I say they get closer and closer to perfect? I will write a formula that's a limit. When x tends to infinity, f of x and this equals 0. That means this curve and this straight line are closer and closer to each other at infinity. Okay, now if you can find something like this, then there is an oblique asymptote. Now, another confusion is between these two. Horizontal and oblique. Now, oftentimes you will see the teacher find one and ignore the other one. Later on, you will see me do this. In this question, I will go find the vertical asymptote and the oblique asymptote, but I will ignore the horizontal asymptote completely. Like, I don't even consider there is one. Let me explain. Oftentimes, horizontal asymptote and oblique asymptote do not occur at the same time. Why is that? Why is that? This is because if at infinity, the function tends to be, it shouldn't tends to another thing like this, because the limit cannot be both. Do you know what I mean? Oftentimes, if you consider a normal function, it doesn't have a lot of lines, just one curve. The one curve shouldn't tend to two values. Oh, it tends to be at the same time tends to mx plus c. That's why I either find the horizontal asymptote or I will find the oblique asymptote, but I will not attempt to find both at the same time. In one question, I will not. Now look at the answer. For this one, let me write it here. Part B. Because limit x tends to 2 positive, 2 plus x minus x squared, x plus 2 equal. Now this one I will use a calculator. I will put negative 2 positive, negative 2 positive, negative 2 positive. So I will put in negative 1.9. 2, 1.9, 1.9 squared divided by, it's negative infinity. Okay, and this one, I think, now to the left, I will put in negative 2.1. I think it's positive infinity. Right? And I will say, oh, the vertical asymptote. X equal negative 2. Now, some students don't write this. They don't want to write this. They know there is. Now they told me that, oh, Ms. Chen, I already know it's so simple. There must be one. Some of them want to stop, like skip this step. I think it's fine because it's so obvious. Because at x equals to negative 2, it has to be infinity. The denominator tends to 0. Do you know what that means? That means the value tends to infinity. And it doesn't matter whether or not it's positive or negative. Doesn't matter. If it tends to positive infinity, it goes up. If it tends to negative infinity, it goes down. Either way, either way. But why do we find it? It's in preparation for part C. Okay, right now it's not so important, but for part C, when you sketch the whole curve, it's going to be useful because I'm telling you where this curve goes. Okay, that's one part. Now, another part, the other asymptote. You see, I know it's either horizontal or oblique, cannot be both. And I opt for oblique. Why? Because in my mind, I already know this value, the numerator, is much larger than the denominator, if you know what I mean. The numerator is much larger than the denominator by, one moment. Sorry. Now, I was talking about, you see, this is the numerator is of degree 2, and the denominator is of degree 1. So at infinity, they can never be, they can never compare. The square one is always going to be bigger than the linear. So I don't even set out to find the horizontal. I know it doesn't exist. I know. That's why I will say, oh, let's find the oblique, and the oblique is easy. Now I will do the long division. The long division. I don't have a space. I'll do it here. Okay, and then we know that y equal, not y, f of x. F of x is equal negative x plus 3 plus a fraction, negative 4 divided by x plus 2. And if I take limit of f of x minus negative x plus 3, the limit is going to be 0 at infinity. Now, because of this, the negative x plus 3 is the asymptote. The oblique asymptote. And there is no horizontal. That's it. Now today I'm being extra patient about this concept. I hope you fully understand why is that. And then because when I see when I see your homework or the test I marked yesterday, I still see, even if you don't mind, allow me to mention Charmaine's answer also, like very awkward. She got all correct, but very awkward because I see that she wants to find all of them. She wants to find this, find this, find this. It's like in her mind, all of them must exist. It shouldn't be. It shouldn't all exist. Just a type or two. Do you see what I mean? Now the curve. Now the curve with this table, it really should be easy. Let me find a place. The table. I will draw -2, -1, -2. That's one line. Another line is y equal -x plus 3. So plus 3. This is 3, 3, -2. Now I draw the straight lines very fast. You should too, because after all, how many years have you studied the equation of straight line? And then the maximum minimum, -4, 9. Obviously here. I think it should be there. If you plot -4, 9 here, your graph would be wrong, right? It should be in the correct region, -4, 9. The other one is 0, 1. And concave up, do you see concave up? See concave down? That's it. Concavity. Now you can use the increase, decrease as well. You say decrease, increase, increase, decrease. You can see the sign. But using the concavity, I can already plot the curve perfectly fine. And that's the whole thing. Now, girls, I really encourage you with math. I don't know how, I know you work so hard to get a good mark. And some students blame me and say, oh, you don't give me enough exercise. You don't give me, you don't do this, you don't do that. The only way is to understand. If you understand that everything is easy, I don't want you to think math is difficult. It's not. You learn from easy questions, okay? You learn from easy questions. You can solve more difficult problems. I think the questions in the textbook are already challenging enough, in my opinion. So after half an hour, oh, I forgot to say, I really appreciate students coming to the extra lesson because I know I talk very slowly, and I know that it's a save time maybe if you can speed up the video. But I do appreciate you way more. It's not like sometimes, oh, you don't have time. I understand. I understand. Appreciation. Now, we have a question similar to this. Okay, it's not this one. Where is it? This one. It's on the textbook. You can see it on your textbook. Why don't you do this? Okay, why don't you do this? And this time, because I want to see what your work, how you how well you do. Now you show me all that in this. We used to have a Padlet link. Okay, you upload it to that thing. I will repost the Padlet again. Okay, do this. Give you some time. The link is in the Google Classroom now. Now, I'm very happy to see that all of you show maturity, really, in this curve sketching problem. It's so excellent. If I pick Iris, like she doesn't follow my steps, the steps I shown. Like she just wrote down a maximum, minimum, and point of inflection. I think it makes sense, right? This is 1/4, by the way. It's 1/4. 1/4. I think it's fine. It's fine because with the table given, it's okay. And I think it's just 1 mark, 1 mark, 1 mark. Write down, right? And also you can see there is no awkwardness in the asymptote part. You can see the domain, all real numbers, so no vertical asymptote. Clever, right? And also, you see there is no need to do the long division, although you can. I saw some answers with long division, but you don't have to because you know there is no oblique. There is a horizontal one. And then you take the limit, you get the limit, and that is the horizontal one. And you don't even go to look for the oblique one because they cannot coexist, right? Now, I shouldn't say they cannot coexist. I don't see in the way it happens for this kind of function that we discuss. This kind of function, I mean rational, right? Because you want it to tend to a straight line, an oblique asymptote, and also tend to a horizontal line at the same time. The curve must look very weird. In my mind, right? But it's open for discussion. I think you can, with imagination, you can think, oh, maybe there are curves that can do that. There are, maybe. But with this, you see, I don't even look for them. And then the curve with the concavity, this time it's a bell-shaped curve, and it's symmetrical. And the concavity, you see, concave up, concave down, concave up. Excellent. Excellent. Now with the other ones, now some of you did the what do you say? Long division. I should show maybe Emily's. Now you can see hers. In here, she did the long division part. After long division, you still find a horizontal asymptote. Anyway, you see, because y minus -1 is the quotient. Y minus -1 is a fraction, and this tends to 0. So y equals to -1 is our horizontal asymptote. That's correct. I hope. Now in the mid-year exam, you should expect a full, what do you say? a full scale curve sketching, meaning the table won't be given to you. So you must add the signs all by yourself. So that definitely costs more time, but I think the concept is already there. If you know this concept, then combine your skills in the differentiation part with this concept, and then you can do the whole thing. Next question. Wrong. It's this one. This one, this is also very popular because inside one question, there are 2 applications, maybe even 3. Consider the curve y equal this. Now, the question doesn't ask you to sketch the curve, but let's see. Now, where x is positive. Now, this domain is given to you just by force. Now, because naturally, x can be negative as well. Now, if you put a negative number inside this function, you can still get a value out of it. That means it's not naturally undefined. It's just I want x to be positive. Okay. Now let P be a moving point lying on C, the curve. The tangent to C cuts the y-axis at the point M, while the horizontal line passing through P cuts the y-axis at the point N. Wow. I think when you read here, you must know, although the question doesn't require a sketching, you must do a sketching. Otherwise, where is P? Where is M? Where is N? Where is this tangent line and horizontal line, right? Don't you need a picture? Let O be the origin. Denote the x-coordinate of P by U. Express the y-coordinate of M in terms of U. Now, before anything, you need to sketch the curve. And the sketching doesn't have to be coming from first derivative, second derivative, because this curve is a basic curve. So on your rough work, you must sketch a few things. This one. Afterwards, this one. They should be reflectional symmetrical along the y-axis. And then this one, maybe. Because now if this is 1, this must be 3. If you know what I mean. Now you don't sketch this curve immediately. You sketch the original exponential and the reflected one. And then this one is called the enlarged curve. And then you know, oh, this is the curve that we're talking about in this question. Okay. Now, I'm going to show you a beautiful one on the textbook. It's here. It's here. This is already sketched beautifully. So I'm going to paste. So you have this curve. And then I'm going to raise mine. Okay. It's a must. You see on the textbook, it says drawing a rough diagram of the curve C is helpful in solving this problem. It is helpful. Now, I don't draw the whole curve. I just draw the part when x is positive. Now, there is another part on the left, but I don't consider that part, so it's not shown. Look at the screen line. That's the curve. P is on the curve. Okay? The x-coordinate of P is U. So U. Now, how about the y-coordinate? It's not given. Not given, but we can find it. The purple line is the tangent at P. The horizontal line, the orange line is the horizontal line at P. It cuts the y-axis at N. Now, find the y-coordinate of M in terms of U. This is the application where you need to find the equation of the tangent. Let's do that. Okay. When x equal u, y equal 3e negative u. Therefore, P can be found. Now, when I say it can be found, I mean in terms of u. In this question, or in terms of u. Okay. Differentiate dy dx equal 3e to the power negative x times negative 1. That's negative 3e to the power negative x. This is the derivative. How about the slope? Slope of tangent at P equal negative 3e to the power negative u. The slope is a value. It's a value. Okay. Now the equation. The equation of MP y minus 3e negative u equal negative 3e negative u times x minus u. That's the equation. Okay, you can simplify it. Y equal negative 3e negative u x minus u plus 3e negative u. That is the equation. Now, I don't want to really expand it because it has too many terms. Oh, I only need to find the coordinates of M. So substitute x equals 0 into the above equation of MP. We find the y coordinate of M is equal to negative 3e negative u, 0 minus u, plus 3e negative u. And the answer is 3u e negative u plus 3e negative u. To simplify, I will take out 3e negative u plus 1. Okay. That's my answer. That's my answer. B. Find the greatest area of triangle PMN. Let the area of triangle PMN be A. And we already know A is a function of U. So here I'm going to write A of U. I need to find the relation, not to find what A is, but find it in terms of U. So in this case, AU equal 1/2 times base, which is MP. MP, the base, times height, which is MN. MN equal this result, 3EU U plus 1 minus the coordinates of N, which is equal to 3e negative U. Okay. And to simplify, I will get 1 over u, and this one is 3eu, negative u, 3e negative u, and then times u. That is 1 over 2 u squared 3e, sorry, I put 3 in front. Should be 3 over 2 u squared e negative u. Isn't it? Let me check. Yes. I have to make sure this is correct. Otherwise, if you move on, then no. Make sure this one is correct. And then the maximum. And to find the maximum, this is the greatest value. So I need to find the global maximum. Global maximum. Remember here, we still have u is positive. Like later on, when I find the maximum, I will only find the maximum in this range. Now, anything that is higher, but I don't care. You see? Wait one moment. The computer isn't responding. Oh, it's now. Okay. Now here I added this. Later on, I will consider the range. Now a prime, dadu, dadu, 3 over 2, 2u e negative u plus u square e negative u negative 1. Differentiation. Now to take out e to the power negative u, 3 over 2 e to the power negative u, 2u minus u squared, right? And then I have solving a prime u equals 0. I have u equals 0 or 2. Now, you must realize this thing is non-zero. So you don't have to consider, oh, can this be 0? A power. I shouldn't say power. The exponential can never be 0. So these two. Now I will reject this one because you know, cannot be achieved. Okay. And then the global maximum. Now you and I know that since there is only one. Now, since there is only one, technically, right? In this range, there is only one. I can test if it's local maximum, then it's the global maximum. I can do that. I can do that. If it's local, then it's global. There's only one. Now, you can also ignore that and check the value at 2 and also at the 2 ends. But here in this range, we don't have 2 ends. We have x and we have 0 and infinity. You can check the limit there. Now let's use the first method. This method is recommended by the textbook. Now, because there is only one candidate, only one. So I will check if this is a local maximum. If it's the local maximum, it's the global. So the signs of AU prime are as follows. Why don't I use the second derivative? I don't want to because it's not very nice. I don't think it's very nice. U, A prime U. Now, this is U equal to U smaller than 2, U bigger than 2. Okay. Now, I'm not acting. I'm actually testing. Okay. I'm not acting. So this one is negative 0 positive. I actually tested. Believe me. Believe me. I don't want my whole thing to be wrong. So I tested. And it's a local maximum. Now, because there is only one turning point when U is positive, therefore A2 is the greatest value. And A2 equal, I just find out A2 equal 3 times 6 times e to the power negative 2. And this is my answer, the greatest area for this triangle. Is it fine? You still follow? Now, sometimes I think about what your facial expression would be during the lesson, during the actual face-to-face lesson. Some of you look like, oh, Ms. Chen, can you talk faster? But some of you like, I'm already lost. Now, try to digest, okay? Try to digest. Now I've done 2 applications now. The first one, the slope, the tangent, and the second one, the global maximum. Also, this type is called optimization, optimization problem. Last one, it's not over. Last one. If it is given that OM is doing what? OM is decreases at a rate not exceeding 0.5 units per minute. OM is decreasing. It's a rate. M is decreasing. So Eric claims that the area of triangle PMN increases at a rate lower than 0.25 square units per minute when the x-coordinate of P is log 3. You see, I think it's killing, although it's just 3 marks, but still. Do you agree? Explain. Wow. Now, for this concept, the rates of change, I think this one is newly introduced to you. But earlier this year, we discussed locus. This one is very similar because it's not a static picture. It's a moving thing. Something is changing. In your mind, try to imagine P is moving and M is moving, N is moving along. Now, I can show you the animation using the computer, but I think you can kind of, because the green line doesn't change. The green line doesn't change. So P is on it and moving, you see, kind of like locus, right? And doing that, and then it's changing. The thing is that the rate, which one is moving at what rate? I don't think they're all the same. If M is moving down at 0.5, does that mean P is moving at 0.5 as well? I don't think so. I don't think so. It's not the same rate, and you need a relation to find them out. Now, during the lesson, I gave you this diagram, and you have to find all the relation. Now, without the diagram, can we figure out all the relation? How many things are mentioned? Huh? One moment. One moment. Sophia, what do you mean? Can you speak up? Sophia Cheng?
Can you hear me now?
Yes, I can hear you.
I mean, should a sign of A prime U in the range of U larger than 0, smaller than 2 be positive instead of negative?
Huh? You mean here?
Yeah.
What? Oh. Sorry. Sorry. So yes, you're right. I don't know what I was thinking about. Yes, you're right. You're so clever. You actually caught me lying because I said I actually tested. I didn't. I just randomly. You see, bad example. Bad example from me. Yes, you're right. Sophia, you're right. You see, me acting is not very good. I can never be an actress. You see, it's wrong. Yes, the signs are different. I didn't test, I just randomly wrote. It's positive, 0, negative. Yes. That's why it's a maximum. Yes. True. True. And Sophia, obviously, she's very honest, and then she actually tested and find that, oh, the teacher is lying. Yes, you're right. That's the correct sign. Otherwise, how can it be maximum? How can it be the greatest value, right? It has to be a local maximum in order to be the global maximum. Yes. Luckily, I'm corrected. Okay. Now, let's come back. Just ignore that. And come back to this new thing and figure out what is changing here. Now, what is changing? P is moving. P is moving. Okay, P is moving. M is moving. The area is changing. I can say P is moving, N is moving, M is moving, area is changing. Now, I already have the relation between area and P. Okay, I already have, it's already found. This one. The area and U. Now I also have P and U. PU is found. You see, PU is found. PM is also found. Not PM. M and U. M and U is already found. I already know the relation. It's just how the rate is related is a problem. Okay? So don't panic. Don't panic. Just look at it. Right now, OM decreases at a rate not exceeding 0.5. OM. C. d dt OM. The rate is what? Not exceeding 0.5, decreases. So decreases, not exceeding, meaning the rate is not very negative. Now, you must put this in, it's not very negative, it's less negative. So I will say it's negative, but bigger than negative 0.5, if you know what I mean. Now, not exceeding, sorry, equal to. Not exceeding, meaning maybe it's 0.4, right? But it's negative. So it's negative and not exceeding 0.5, meaning it's greater than negative 0.5. And do you know what I mean? So the numerical part is smaller than 0.5, but the value of DDTOM is greater than negative 0.5. Decreases at. Okay. Now here I can put OM inside, because OM is already found. OM is 3 E negative U plus 1. That's OM. Now this obviously needs to be simplified. But right now, let's not deal with this one. Not for now. Not for now. Let's look at another rate. It's the area. Eric claims that the area of the PMN increases at a rate lower than this. Do you agree? Let's find out. Let's not set up an equation because it doesn't say the area. What is the rate of the area? Let's find out the rate of the area. Okay, we already know A. We already know A. Now I just put A inside. A is d dt 3/2 E negative U. Oh, no. What am I doing? 3/2 U2 E negative U. That's A. Okay. Now I need to use this and find this. If I can. Look. Look. Now from this, now I can simplify both. Now from this, now I will know d dt 3 E negative U plus 1 is equal d du 3 E negative U plus 1 times du dt. Okay, now I'm simplifying. It's a function of U. If I'm doing d dt, I need to do d du and then times du dt. Okay, and then the differentiation. The first one is 3 E negative U negative 1. The second one is 3 E negative U and 1. I don't know if you see what I'm doing here. Now to differentiate this, you need to differentiate the first function. Sorry, I'm wrong. you need to differentiate the first function, copy the second function, and then plus copy the first function, differentiate the second function. Almost made a mistake there. Okay, that's the differentiation. Now, in this part, the differentiation is not so easy. It's not just a polynomial. It's a product. It's a product, and inside the product, the first differentiation is not just one step. It's two steps. And then, okay, let me simplify. 3e negative u. This is negative u negative 1 plus 1. So it's negative u. Maybe I put negative sign inside. Negative 3 e negative u u du dt. Okay. And we know that 0 is greater than negative 3 e negative u u du dt greater than negative 0.5. That's my condition. I can simplify this inequality by doing this. Now, if I multiply the negative 1, then this is the thing. This is the thing. Now, for this one, the objective dA dt, I can also simplify. Now, I must do. For this one, I will do dA dt is equal, also a huge thing. But this thing, I will do ddu first. And then du dt. And then it's 3 over 2, 2u e negative u plus 3 over 2 u square e negative u negative 1 du dt. Okay, simplify. When I simplify, I just simply take out e to the power u. E to the power u. E to the power negative u. I'm left with 3u and then minus 3 over 2 u squared du dt. Okay, now substitution. Now the question does give you a point that you need to find. It's not like always, it's just when x coordinate of p is log 3. You just need to verify at that moment what is happening with dA dt at that moment. So now let's do substitution. But when the substitution happens, it has to happen all the places, all the places. So when u equal log 3, let's first substitute inside here. That is 0 is smaller than 3e log 3 times log 3 du dt smaller than 0.5. Okay, therefore 0 is smaller than 3 times log 3 du dt smaller than 0.5. So du dt itself is greater than 0, greater than, this value is 1 over 2 divided by 9 log 3. So 1 over 18 log 3. That's my condition. Okay, now how about the conclusion? The conclusion is dA dt by substitution, it's e to the power, is it negative u? Sorry, negative u, I made a mistake. Negative u. Wow. Negative u. Sorry, I made a mistake. Negative u is 1/3. So only 2 log 3. Sorry. I always just forget to write the negative sign. Now this is 2 log 3 there. 2 log 3. Negative u. Yes, negative u here is missing. Negative u and 2 log 3. Here, this one, if we put in, is e to the power negative log 3 times 3 log 3 minus 3/2 log 3 whole squared times du dt. But du dt can be found. Let me simplify this. This is equal to, this is 1/3. Anyway, this is a value. This is a value. And then it's equal to, just put in 3 log 3 minus 3/2 log 3 squared du dt. And then this is log 3 minus 1/2 log 3 squared. Okay, and then du dt. Now, the question doesn't require an exact value, just to verify whether or not it's slower than, does it increases than a rate that is smaller than 0.5? How do I know? I just need to put in this smaller than, I think this is equal to, smaller than equal to log 3 minus 1/2 log 3 squared, and then 1/2 log 3. Do you know what I mean? Okay, and then you use the calculator. You can find out whether or not. Let me just do it. It's 1/2 minus 1/4 log 3, and that is 1/2 minus 1/4 times log 3. (0.225) smaller than 0.25. And then that's why I should agree or disagree. Lower than, yes, I should agree with Eric, basically. And in the end, the claim is agreed. Okay. Do you see the scale of this question? This is one of the, I think, more difficult question in the exam. I mean, not in the mid-year exam, but in the public exam. A lot of applications, and not clear, not the same, like the given condition is not du dt. It doesn't give you, oh, what is the rate of du dt? It doesn't give you. It gives you another rate, which is, it's already unclear. You see, this rate is given to you. ddt, this is given to you, but not equal to something, but smaller than something, or greater than something, right? And then this one also is not a simple, you still have to do the differentiation. Now, I think the way to succeed in this type of question is to know what relation you have at hand. What is given and what you need to find. If the function is already found, then obviously use it. If the function is not given, it's not found, then you have to find it and then differentiate. In the end, no matter what, you're just getting the relation. Now here the relation, if I show you by the diagram, it would be the position of P, which is just U, and then A and MU. Now all of them are related to U, basically. But their relation, for example, what is the relation between A and P? We don't know. We don't know. So I think it's more like this diagram. Sorry, it's something like this is U, and then related to U, related to U, related to U, like this. Instead of like, oh, A and M, what's the relation between A and M? No, we can't find it. We don't know. But it's not like it's not there. The word implicit means it's there, I just don't say it. Implicit. So the relation is implicit. There is one, but I don't have the ability to find it. I don't have the ability to find the relation between M and P, or A and P, but I can find the relation between AU, MU, and PU. And all of them are related. You can see that. Now, because, let me illustrate. Now, because dA dt is related to du dt, you see? And this dt, this given, this is M, this is M, is also related to du dt. This is also related to du dt. Everything is related to du dt, that's why in the end you can find it. Now you have to try, otherwise whatever I say doesn't, it won't really give you any impact. There is a similar question on the textbook. Similar. You can try. And you let me know. Now upload and I will check. Okay, it's a long task. And you have 20 minutes. Now, when you're done, you upload to the new Padlet link. I just uploaded a new one. Okay, hello girls. Now I know you may not have finished, but listen to me. I have a few comments to make. 3 students turned in their solutions. I think, according to the handwriting, they are Cassandra. This one, I'm not sure, maybe Justina, maybe. And this one, I think it's Sophia. Now, Cassandra and Justina, maybe. Maybe, I don't know. Is Justina even here? No. Then it's not her. Who is this then? Hey? Who is the second girl? Who is this? Hey, yeah. I know. Nah. Like they didn't show the graph. They didn't show the curve. I don't know if you think it's important. And this one, sorry, I didn't I didn't, sorry. It's not even here. Now these 2 students, they didn't show the curve. And this one, Sophia, she drew the curve. Now, although not exactly like that, the real curve looks like this. Now, you may say, oh, Ms. Chen, how do I know the curve look like this? Knowledge, because I know when x is smaller than e is decreasing, when x is greater than e is increasing. It comes from the derivative. I know. Now, if you want a more accurate curve, you have to look at it because this one is not a basic curve. So this is the correct curve. But Sophia's is not so wrong because it doesn't affect her answer. Now, as long as your curve lies in the first quadrant, it shouldn't affect the answer of this question because later on, when you find the area, you need to use the coordinates base times height. And if it's in a different quadrant, then the base and height may be different. But in the first quadrant, I think it's okay. So this curve, although not entirely correct, but still workable. Okay. And in part A, you get k equals to 4. Now in part B, there is only one turning point. I think this is what she's saying. There is only one turning point. So the local minimum is the global minimum at x equals to e to the power 1 over 2. Okay. The last one, OQ is increasing, not exceeding 2 units per second. So du dt is smaller than or equal to 2. And I believe Hei's answer is strictly smaller than 2, smaller than or equal to 2, smaller than or equal to. Now, and then the dA dt, in this case, ds dt can be found. Now, Hei, I don't like why you use x here, because in part B, you're using a. You see? If you use a, you use the a all the time. If you use x, you should use x here as well. So I got confused while looking at this. So you're using x again. That's fine. Then you change everything to x then. Okay. And this is dA dt, and then this is dA dx times dx dt. And then when you put x equals to e inside, it's smaller than or equal to everything put in, everything put in. And also the dx dt, you put in smaller than or equal to 2. Then it's not equal to, it's smaller than or equal to this value. And this value is smaller than this given value. I think it's smaller than or equal to 4e. And smaller than 45/4. That's it. I don't know. Maybe you need more time to figure out. Is this Sophia's answer? I'm not sure. Sophia, is this your answer? Yes.
Yes.
Why does Iris say yes? Iris, why do you say yes? Did you finish, Iris? Good. Good. And I don't know why I deleted the previous Padlet link, so I uploaded a new one. Now, girls, follow my guideline. Now, for me, I know other teachers maybe they want to always give difficult questions. Now, if you understand, then everything is the same. Believe me. I strongly encourage you to find some question to practice. Not everything, but some, like reasonably, maybe 1 or 2 in each exercise. Now you find 1 or 2. Now if you find, oh, this is too easy, then you try a more difficult one. You find 1 or 2 to try and see if you can complete a long question. If you can complete the long question, then why do you worry? Why do you worry? I should also mention the answer to the summer holiday homework has been uploaded. You should go to check your answer. If you find a mistake, then correct it. And then that's enough. You cannot restudy it. Please don't. Okay? There will be only one question about trigonometry, and it's not difficult at all. I already mentioned you don't have to really study the sum to product sum. Well, it's not necessary. I just want you to use the basic ones. And the sum to product sum, I don't consider them very basic. Usually they are used when angles are complicated. When you have the sum and the difference head to friend. But our exam, I won't give you so many angles. It's just 1 or 2 angles. That's it. Okay, so know where to put effort on. Unless you have any further question, you are dismissed. See you.